Bismillah ar-Rahman ar-Rahim. My name is Dr. Inayat Ur Rehman, and today I will discuss the priority queue and double-ended queue. First of all, we will review the last topic, which was about the FIFO queue and circular queue. After that, we will discuss the priority queue, its operations, and then we'll discuss the double-ended queue. First of all, review the last topic. Q is a data structure or abstract data type which follows the principle of first in, first out. That means the value entered in the queue first will be served first. The common operations of Q are NQ and DQ. And the supporting methods were is full and is empty to check whether the queue is full or not and whether the queue is empty or not. We can implement by the queue by a class structure. In last lecture, we discussed the implementation by a class. So to implement the queue, we created the structure or class named the CQ. As we discussed in class that there is no major difference of structure and classes, except in structure all the data members are public, and in class we have to specify them as public or private. So by replacing the keyword class by struct and removing the public or private access specification, rest all is the same. Like CQ class, we can change class to struct and rename the class with struct, and removing the public and access specifications, we can convert it into a structured class. So in main, there is no change, and creation of object by structure and class will remain the same. So repeating this point, that there is only one difference, which is we change a class with struct, and secondly we have to mention that whether in structure we in classes we have to specify that the data is public or private. Then as in classes the data is by default in C language, the class data members are by default private. So in structure we no need to mention that the data members are private or public. So simply we change the class name class with struct keyword, and then if there is any access specification, we can remove that to convert it a class into a structure, and rest all will be the same. So a priority queue, first of all we discuss the priority queue. A priority queue is an abstract data type which is like a regular queue data structure, but additionally each element has a priority associated with it. In a priority queue, an element with highest priority is to be served first. The priority queue is extended form of ordinary queue, except that the DQ operation is performed on the basis of priority. So a priority queue is different from a normal queue because instead of being a first in first out, values come out in order of priority. An element of highest priority always appears at the front of the queue. If the element is removed, the next highest priority element advances to the front. Let's say you are in charge of a hospital, managing the patients in the waiting room. There is only one doctor to check the patients. All sort of patients are coming in the random time, each with a different injury. Who gets to see the doctor first, and in which order should they be admitted to surgery? Common sense is that the person who is most hurt should be treated first. In other words, the doctors should see the patient in order of how badly they need treatment, no matter what order they actually come into the waiting room. Suppose two patients come in hospital. One is with paper cut injury and other is hit by X. If the hospital runs first in, first out procedure, then the guy with the paper cut would be treated before the guy with the X in his heart. The guy with the X is in his head should be treated before the guy with the paper cut, because otherwise he is going to die. That's why a priority queue is for if you need to handle something with a higher priority first, regardless of what order the item arrives, you need to implement the priority queue. So, the difference of priority queue with a FIFO queue is that in priority queue we have a, each member have associated a priority with it. So a priority queue so in priority queue every element has some priority, but in ordinary queue the priority is based on first come first served basis. In FIFO, the enqueued element is automatically placed at the end of the queue, but in priority queue, it is adjusted according to the priority associated with it. If more than one element exists with same priority, then the FIFO will be applied for these elements. Consider an example of priority queue. If the queue is empty and we enqueue the value 8, then the value will be inserted at index 0 like an ordinary FIFO queue. And if the priority is based on the smallest value to be served first, then if we enqueue the value 5 after 8, then the 5 will be adjusted before 8 as 5 is less than 8, but as per our rules the less value will be served first. So 5 will be adjusted before 8, and then if we enqueue the value 12, then it will be placed after 8. So 12 is higher than last value, real value of the queue, which is 8. So 12 will be placed after 8. And if we enqueue 3, then we have to adjust it with while comparing with remaining all the elements of the priority queue. First of all, we compare 3 with 12 as 3 is smaller than 12. So then we will compare it with 8. Again 3 is smaller than 8, and after that we will compare it with front value which is 5, and again 3 is smaller than 5. So in this situation the 3 will be adjusted at the front of the queue as it is of highest priority. Consider then we enqueue the value 7, and 7 will be adjusted as per its priority. So first of all we will compare it with 12. 7 is less than 12 and is of higher priority than 12. So again we will compare it with 8, and again 7 is of higher priority than 8 as 7 is less than 8, and the priority queue is maintained as per the rules of smaller value to be served first. So we will adjust 7 before 8, and then we will compare 7 with 5. Now you can check that 7 is greater than 5, so 7 should be placed after 5 and before 8. So consider the DQ procedure as in FIFO queue, ordinary queue, we dequeued the element which was at index 0 pointed by the front pointer. So again here we will apply the same process and dequeue the value which is placed at the front of the queue. First of all, when we apply the dequeue process, then 3 will be removed first. Then if we apply again dequeue, then 5, and after applying again 7, and last if we apply dequeue, then 7 will be removed or dequeued. So regarding implementation, we can implement the priority queue by statically and dynamically. Like in previous class, we implemented the ordinary queue, FIFO queue, by static implementation and by dynamic implementation. Again, here priority queue, in priority queue we will implement it with static and dynamic data structures. First of all, static implementation by array. So, first of all, we create an array named A to hold the priority queue elements, and then we initialize of the array, size of the queue as 5, and after that we create initialize starting index and last index by -1, as initially there is no element in the queue. So after that, the methods priority queue, priority insert, and delete from front will be applied. So to enqueue in priority queue, first of all we define the method which is named here as priority insert. To define the method of enqueue, a method priority insert is based on the priority of the value. First of all, we check the availability of space by checking the last index. If last index is at size -1, then we inform user that there is no space in the queue, and in case of false value return by if statement, we come to know that there is space in the queue. So the program moves to the else part if there is space in the queue. After getting the input from user, as we know that there is no issue of space, first of all we check that where the space exists. If the queue is empty, then move starting index and last index to 0 index, as this value is first and last value of the queue. If the queue is not empty, then first of all we compare the value of last index with the new input, and if the value x, which is new entered value, is greater than the value of last index, then we simply place the new value after the index pointed by last. So in else part, there is space in the queue and the queue is not empty, and also the new value is smaller than the value at the last index. Now, as the value is less than the last index, so we have to shift the values until we find the value which is smaller than the new value. The while loop executes until array of I, q of I index, is greater than x, and we reach at starting index. Till that time, we copy the last index value at last index plus 1. So we have to shift the elements to right side until we find the place at which the new element is to be inserted. So simply in while loop we define it as while a of I is greater than x and I is greater than starting index. So we are using AND statement, AND operator. So if any of the condition becomes true, becomes false, then we will exit from the loop. So, in first part of the while loop, where we check that if a of I is greater than x, if a of I is greater than x, as I is pointing, initially the I is pointing at last index. So, if a of I is greater than x, then what we will do, we will check that I is greater than starting index. If I is greater than starting index and a of I is greater than x, then we will shift the value of I to a of I plus 1. So we will copy the value of I index at array of I plus 1. Then after that, we will apply the decrement to I, and we will check again until we find the value which is greater than, we find the value which is smaller than x, or I becomes reaches at the starting index. So when the loop terminates, then we will place the value at a new value which is x at I plus 1 index, and after that we will apply the increment to the last index. So by static implementation there are some issues. As we discussed in earlier uh, ordinary queue, there are also issues of memory management in priority queue. Like if there is only one element in queue which is at size minus 1 index and we want to enqueue another value, then the message appears that there is no space in the queue. Although we have space, so we can solve this issue by two ways. First of all, after dq shift all elements of queue to left, but this method is costly. Another good solution is to implement the priority queue by circular queue. So we can implement the priority queue by circular queue to avoid the memory management issues. Moving to dynamic implementation of the queue. For dynamic implementation, consider the example of hospital where patients are checked on the basis of their age. To implement this task, we have created the structure having data members, age, and name of the patient, and a pointer next of the queue type, which points to next node or next node of the record. After declaration of structure, we created two pointers of PQ type named front and rear and assigned them null value so that they may not point any garbage value or become the dangling pointer. So to enqueue, after creating the new node named current of priority queue, first of all we check that whether there is any element in the queue or not. In case there is no element in queue, then the new node, which is named here as current, is the first and last node. So the pointers front and last will point to the same node in case if the first front is equal to or rear is equal to null. In case if there is no value existing in the queue, then first and last both will have null value. So first of all, we created in enqueue method, first of all we got two pointers named current and q. And by current pointer we create a new node by using the new operator. So after creating a new node, we get the value from user as first of all current of name, then current of age. So after getting input from user, sorry. So after getting input from user, if front is equal to null, then front is equal to rear is equal to null. Rear is equal to current. So if front is equal to null, that means there is no value or there is no chain or there is no queue already in the memory. If there is no queue, then front or and rear will have null value. So if front is equal to null, so first of all we assign the value address of current to front and rear so that front and rear may point to the new node. So there is only one node in the memory which is at the location of current. And in case if condition becomes false, then we check whether the current of age is less than front of age. If the current of age, current is the new node which is having the new value entered by the user. If current of age is less than front of age, front is a pointer which is pointing to at the first node of the linked list, first node of the queue. So if current of age is less than front of age, then simply we connect the current node with the first node by current of next is equal to front. So when we link the new node, then after linking we move the front pointer to the newly created node which is current node. So we change the front as front is equal to current. And if front is not null, that means there is a chain, there is a queue in the memory. And again, if current value is not less than front node, front of age, then we move to else part of the enqueue method. In else part, first of all, we create a pointer to hold the address of front pointer. So q is equal to front. And we move the, again we check and move the q pointer until we get the location where we will link the new current node. So in while loop we check that if q of next is not equal to null. As you know, while is similar to if condition, and basically if it is if condition which checks multiple times, as if check there, if q of next is not equal to null, if I replace while with if, then if q of next is not equal to null, that means we do not reach till the last node, and q of next of age is less than current of age. So again we check that if we have to move to the location where the new element can be adjusted. So first of all, we will move until we find the last node. And second condition is if q of next of age, let's say if q is, you are having values 5, 8 and 10, and now you have now the new value is 9. So we will move until we get the value greater than 8. So if we are at index at node 5, having a node at having value 5, then we will move again to next node which is having value 8, and after reaching at index 8 we will compare with the value 10. So assume that q is at index 8. Q is at index 8, our node having value 8. If Q of next of age, Q is at having value 8, Q of next is having value 10. So Q of next of age, if Q of next of age, Q of next is 10. So if Q of next of age is less than equal to current of age, then simply we will connect it with the new node. So the while loop will terminate, and then we will connect it current node with that node which is after the Q pointer. So in DQ, the DQ is similar to for the implementation of ordinary queue. So the DQ operation, in DQ operation, first of all we will check whether there is any element in the queue or it's empty. If the queue is not empty, then we remove the first element of the queue as it is of highest priority. Here you note DQ method of ordinary queue and priority queue is same. As in ordinary queue, we DQ on the basis of first in first out, and the first one element to be dequeued is at index 0 or first as are pointed by the front pointer. Here again in priority queue we have same order, that the element of highest priority is always at index 0 or is pointed by the front pointer.